right, there's three more topics to talk about, just so you know, in this chapter. First, we're going to hit on polymorphism, then on abstract classes and abstract methods, and then finally on interfaces. So there's not that much page-wise, but complexity-wise, these are probably the three hardest parts to understand in this chapter. Okay, so I kind of alluded to this before, but I'm not going to keep this stuff. This is just some garbage junk that I threw up there. But imagine that I came up there and I created, and I just called this animal. All right, and I came, and I'm going to change this a little bit later, but I came through here and I said this. I said there's public. We'll say string speak. Okay, and when you call this, it'll say something like system.out.println, and I'm not even going to put anything in there. But if you tell it to speak, okay, well, hopefully you'd all agree that if I come down here and do this, whoops, that should be a capital H. That should be a capital A. That one of the first things I'm going to want to do in here, so again, I put the little dot, dot, dot in here because there's other stuff we'd want to do also. All right, but one of the things that we'd want to do in here is we'd want to override this. All right, so we'd want to say public string speak. And then if I came down again, I'll just do one more because that's plenty. And I said, it's not going to say hi. If you do, you probably really have something there. But all right, but something like that. Does all that make sense? All right, if I call the speak method in Java, if I call the speak method, the right one will be called. How does Java know which one to call? It's not a trick question. How does Java know which speak method to call? Well, you're making it even harder than it has to be. It knows which speak method to call based on the kind of object I have, right? It knows that if it's a dog, it says woof. If it's a human, it says hi. If we put a cat in here, it'd say meow or whatever. Does that make sense? So it knows, even though we've got multiple methods with the same name, it knows the one to call based on the context of who's calling it. Does that make sense? Because that's polymorphism. It means many forms. So when you've got, again, if I came back in here again and took this, all right, and then someplace on later down in my program, I do this. I say, what do we call it? Human Mike equals new human. Mike dot speak. We know for a fact it's going to say hi. That's just the way that it's set up. It's kind of ingrained. I don't know exactly any other way to say it. On the other hand, if I go through here and I say dog Max, I don't know, equals new dog, and we do max.speak, we know that Max is going to say woof. And if we say cat, Fluffy equals new cat, and we say fluffy.speak, all right, based on the type that you're using, it knows to say hi, woof, and meow. Does all that make sense? Because that's kind of the hallmark behind this. All right. So I'm giving you very simple examples on purpose because sometimes when you see it in the code, if the code is too complex, it gets to be confusing. It doesn't have to be. It's the way the person implements the concept is what makes it confusing. It's not so much the concept itself. Yes. Yeah, you're right. You are right. These all should have been. Thank you. Yeah, this should have been. That's human. No, they all extend animal. Right. Question was, if you did, probably what you do is you probably call super first, and then it would say hi meow. But if you didn't call super first, it would just say meow. That said, I mean, you know, because of the context of the way the mammal food chain works, that wouldn't make a lot of sense. But it's a good question, though, because sometimes people do things like that. And no, and it doesn't care. What it's actually looking for here is, if I do come up here, and let's just say, well, we had human up, or animal, let's say instead of putting nothing in there, I just put in this. Okay, I just put that in. I don't even know what that is or how you'd say that. It doesn't matter. But the point is, if I now pull this out for dog, if I don't have anything in here, so let's just pretend for just a second, this is gone. All right, so right now it's gone. So now when I say max.speak, it says, oh, there isn't one here, so it looks to the parent to see if the parent has one. It finds it, so now max goes her. Does that make sense? Because this is known as being one of the hardest to understand concepts in object-oriented programming. And I'm not saying that it's easy, but I think a lot of times the reason that it's hard is people make it harder than it should be. And a lot of it has to do kind of like what you were saying. And I knew your question was innocent. I don't mean this in a derogatory way, but people try to do things they shouldn't do. In other words, they'll sit there and they'll try to make a child do something that it isn't supposed to do, or make a human do something that a child, and sometimes some of that stuff you can actually do depending on the language. All right? And let's face it, if you know language and you learn another language, and somebody says, oh, you know C? Oh, and you just learned D? D is a lot like C. You start trying stuff to see what will and won't work. And if everything that you tried in C worked in D, if it was exactly the same, why would you write D? All right, there's got to be something different about it. And if there isn't, it's not going to stick around as a language long. Oh, I think, who's in trouble? Oh, was that today? Yeah. Oh, okay. I didn't know if I was supposed to look and figure out how many hours.
Nope, I'll do all that part.
All right.
And it just started last week.
All right. Where do you want me to sign it?
Sign and date. And this will just happen once a month. So I'll do the dirty work.
All right. Thank you.
Thank you.
See, I was a bad person. She gave that out 3 days ago and said, "Bring it, have it signed and given back to me by Thursday," and I didn't do it. So. All right. Now, they also talk about here, you can see this, important enough. See if I can copy it to the clipboard. I love the way this copy thing works in here. Actually, this one might be all right. All right. First, I just want to talk about this. And maybe you've heard me say this already. I don't know. Dynamic binding is also known as late binding, which would make sense because the other one's typically referred to as early binding. All right? Do you know how in Java, if I do this, if I say int bracket bracket grades, all right, and I'm making an array, and let's say that I do that, and I'm doing it for everybody in this class, and there's 10 of you. Okay, so I'm doing that in the Java program, ... meaning I have some code. Later on, I decide I want to make grades bigger. Can I? You want to answer? Try that again. Can I? You want to try it again? Can I? No. I can make another array that's bigger and copy all this stuff in, but I can't take a Java array and change its size once it's been created, because Java arrays are set. They're early binded, which means they're set at compile time. So when you go to compile the program, it needs to know exactly how much memory to allocate, etc. Now, on the other hand, if I'd asked that question, instead of saying Java, I said JavaScript, the answer is yes. So you just didn't hear the script part, all right? Because I said it real soft, all right? And with JavaScript, the arrays in there are late binded, which means the stuff is set at runtime. Rather than at compile time, it's set at runtime. That's why you can ask the user a question in JavaScript. You can say, how many students do you have? All right, you can do it the same kind of way, but what I'm saying is I can sit there in JavaScript and I can say, how many students do you have? And I can say 10. And I can make the array of 10 like this. Oh, I forgot we just added 5 more. So I can come through here and I can just say int, or not even int, I can go grades in JavaScript. I can say grades 11. I can do that. 12, 13, whatever. You can't do that in Java. You can't do that in C. You can do that in PHP. PHP and JavaScript have a lot of things that are similar to one another. All right. Now, what's funny? You know, no one's asked, so I'm going to ask the question. Pretend for a second I'm one of you, and say, well, how about one of the languages we're going to learn? How about Objective-C? And in Objective-C, they let you create 2 kinds of arrays. You can create what's called an NS mutable array, which means it acts like this. You can also create an NS immutable array, which is like this. So you can do either one. And hopefully it doesn't surprise you too much. NS immutable array is this one is a child of the other one. All right. So it's always language dependent as far as what you can and can't do. All right. So when you hear early binded, it means at compile time the system has to know what to do. If you hear late binded or dynamically binded, it means it's while the program's running, it can do that. Now, typically, programs that are late binded are going to run slower. So you're always looking to optimize those because you're allowing the user at runtime to figure out what they're passing into it, how big it's going to be or whatever. All right? So that's what they're getting to. It says when a superclass, yeah, potential problem exists. What if a subclass has overridden a method and the variable makes a call to that method? Does the variable call the superclass's version or the subclass's version? Kind of what you talked about, Mike. All right. What it does is it looks and it says, oh, does the child have one? And then it calls that one. And if it doesn't, it goes to the parent. What if it goes to the parent and it doesn't find one? What do you think it does then? It doesn't stop. It goes to object, and it sees its object has one. Then it stops. And those are considered exceptions in Java, and the program will just blow right there. All right, so it'll always look where it is, and it'll go up the stack, the parental stack, so to speak. All right, so with what we looked at before, if you imagine that all those things were, you know, one of those hierarchies we looked at with a graded activity and all that, it'll look at the child, then at the parent, then the grandparent, then the great-grandparent, etc. Eventually it runs out of parents, it goes up to object. If it can't find it, not only that, it uses the first one it finds. You say, well, I didn't want it to use that one. I wanted to use, no, you can't do that. There's not even a way programmatically that I know of that you can do that. It might be possible that I could use the parents, and then the parent would call super to call the grandparents. You see what I'm saying? Boy, if you're writing code like that, it's getting really convoluted really fast. So there might be a better way to write it. But this is some of the stuff, again, that we've talked about. I'm not going into some of the stuff that they talk about here because it gets to be very confusing. And it's not my goal to confuse you. All right? You may not agree with that, but it's not anyway. Yeah, there you go. Yeah, it's just a perverse joy that I get, that's all. Yeah. So again, you saw this. This is a child of final exam. So final exam, you can't do this. And let's look at this example here. So the author is saying right here that this, that should be equal. That's why I said this just copies just really well. All right, that's equal. Now I'm going to grab this. There's a reason for doing this. It's not to waste either one of our time, but graded activity equals new graded activity. All right. And I probably won't put it up here the way I want, but I'm gonna try anyway. All right, that's legal. Final exam, boom, boom. That's fine. But what you can do is you can come in there. Let's call this exam 1 and exam 2. Try to keep it simple. All right, so that's an error. But if I come through here, that you can do. Because what this is saying is, I've got final exam. This is an error anyway, so let's just get rid of that line. So we're creating, that's a parent, remember, call this. So the child, we're setting equal to a parent. And that's, again, what is that saying? The child can do anything the parent can do. But the reason this didn't work is we're trying to make the parent do anything a child can do. The good news is, if that confused the hell out of you, then just don't do it, because if you try to do something illegal, the compiler won't understand, so it'll complain. And it won't let you do it anyway. But again, I've seen people do this, and in some ways what they're doing is they're just stretching stuff to the limit to say, well, I just want to see what would happen. Right. But that's like somebody who tells, try telling that to a cop. It was funny because this morning I drove by a cop and I was going 47 in a 40 zone. And at first I really I did hit the brakes right away. I passed him, so it wouldn't have mattered. But I thought, okay, I almost hope he does try to pull me over. It was a Wisconsin cop, because I was going to get every bit of information because the guy on the left was going faster than I was. He didn't pull either one of us over. So, all right, there is something in Java that exists that's called the instance of operator. Notice, you can use to determine whether an object is an instance of a class. Remember what objects and classes are? The class is the blueprint. The objects are the type that you create from the class. All right, so you can check. Notice, so we created graded activity, which is a type of graded activity. This wouldn't have to be in the next line. You could do it somewhere else. You could say, is activity an instance of graded activity? And it'll say, yes, it is. Notice it says it understands the is-a relationship. It says, for example, look at the following code. All right? And it says final exam equals new final exam. If exam is an instance of graded activity, all right, say that it is. If one is a child of the other, it'll still say it's an instance, is what I'm getting to. Does that make sense? Again, this is fairly complex stuff. The good news is we get in the next chapter, it's fairly simple. All right, we talk about exceptions. You're like, good, because my head hurts now. All right. When do you use an abstract class? I left this up here before because there's actually an example of this. True or false? Probably. All right, at least true or false. You're never going to create an instance of this class. True or false? True or false, and if false, why? Yeah. Would you ever tell somebody I bought me a new animal yesterday? Would you tell them that? Probably. Would you? Why? Because you're both right. Because you want to be more specific. So you probably, rather than saying this, and I want to give you the right syntax, what you probably would end up doing is you do this. Which means now you cannot new that class. You can still inherit from it, just like this. That's totally fine. But then when you write speak, you'd write it like this. And what that means is any class that inherits from animal must have a speak method, and it must return a string. But what goes inside of the curly braces here could be anything in the world, and they don't have to be the same. They could be totally different. So if you had something else that spoke in an entirely different way, that was, I can't think of something, but if you get the idea. All right, so what this is, this class cannot be nude. So if you were to come back up here and try to say, the way we wrote it before we had the word abstract in there, that would have worked. But now that it's an abstract class, this will give you an error message when you try to compile it. Abstract means it's just something that you're using as a base. The kind of classic one that people use rather than animal, which is one that's used, is people use, they create a class called bank account. And it's all the stuff that any bank account would have regardless of type. Then you create a class checking account that extends bank account. And you create a class savings account that extends bank account. Get the idea? That kind of thing. All right, so that's usually how it's used. Not only can you make classes abstract, you can make methods abstract too. Totally legit. That doesn't mean they're not nude. That means that you can only have abstract classes in, you can only have abstract methods in abstract classes. Usually, that's more or less what you see in abstract classes, are a lot of abstract methods. This is a contract. Look at it this way. Remember a long time ago one day we talked about APIs, application program interfaces, and I said that's a contract? That's a software contract, and if you're going to use the API, you can use all the stuff that's in it, but you have to agree to use it that way. You're kind of doing the same thing here. I'm saying, okay, I want to be able to extend animal. And that says if you want to extend animal, you have to have one of these. If I leave this out of here, I get an error message. And it's going to tell you, almost specifically, that that class extended an abstract class and doesn't include the abstract method. So they come in here, and the example that they give in the book here, it's like 643 or something like that. So you can see how well my pages map up with those. And that's 643 in my book, 669 in this book, because my book doesn't have a couple of the chapters that your book has. So an abstract method, this is wrong, is not instantiated. Cannot be instantiated. That's what it should have said. Not is not, cannot be instantiated. But he's right, other classes can extend it. It has no body and must be overridden in a subclass. So here's an abstract class student. They've got some data in there, and then notice what they have. You can write regular methods. You can do that. All right, and then they come over here, and then they say, now you've got a computer science student. Do you see the advantage of doing this? For instance, students here. Imagine that every single person who came into Blackhawk, and last time I heard, there's between 4,000 and 5,000 people at all the campuses combined, full-time, part-time, whatever. And I'm talking about credit students. All right, when you came in here, let's just say they pigeonholed you in that you all got put into a program. Everybody did. Okay, so they decided to create a class called student. Okay, and all students have this stuff in common, whatever this stuff is. I guess the stuff they're talking about in here. All those students, they have a name, they have a BTC ID number, when they were admitted, etc. All right, but then they start breaking it up, and they put you into each program. All right, so Mark might be instantiated as a computer science student. All right, Bill, who's not in here, might be instantiated as a culinary arts student type of thing. They both would have all that stuff, the name, the ID number, etc. So you can take common core stuff and you can define it in an abstract class, and then you extend from that class. The reason that you might want to make that the top class abstract is it's so generic in nature that it makes no sense to ever new or instantiate that class. That's why you make it abstract. So what you're getting in here in this lecture, and I'm not saying this good lecture, I'm saying in this lecture, is a lot of object-oriented terminology and a lot of object-oriented theology, for lack of better words. All right? Because even if you made this a non-abstract class, it would all still work. All right? But the thing that you can do in an abstract class, if you want to, is what I showed you. You can come up with the name of a method, and you don't have to put any implementation, because you know that an animal can't speak because it's abstract, because you're never going to know it. But you know that every animal that you create that extends animal, human, dog, cat, fish, well, maybe not a fish, but whatever, they're all going to speak in different ways. All right? And that's what they get to in here. I mean, that's what they're showing in here, okay? So there's a computer science. And what's the difference? Well, I don't know culinary, but as an example, culinary is probably not going to have a computer science hours taken. There you'd want to change that to something like culinary arts hours taken or something like that. All right. Interfaces. This is the last, is this the last topic? Sure looks that way. Yep. About 10 more pages left in the chapter. An interface specifies a behavior for a class. What? Well, look right here. This is a great example. See that code listing? It's in your book, I guess, on page about 675 approximately. But you see this? You save that. Notice it's a Java file. What doesn't it have in it? Every Java program we've ever done, what doesn't this have in it? No. Yes. You've created classes that don't have mains in them. A demo class has the main in it, but the class that you're demoing doesn't have a main in it. There is no word class in here. So if I create this, I'm sure this will copy real well too. If it's real ugly, I'll just forget it. I'll just tell it to you. So. Oh, that's not terrible. So let's say I did this. All right. In English, what this is saying is, okay, what I'm defining in here, I guess there was a G in there, but what I'm defining in here is an interface. All right. Now I'm going to define another one. There's actually a reason, so just hold on for a second. All right. So we're just kind of dumb name, but relatable too. We'll call this not equals, and rather than is greater, we'll call this, how about is greater or equal? Okay? Is less or equal. Where this is different from what we've been looking at so far is now I can come through here and I can create a class. Public class, a new class. I'm not worried about extends, but I can say implements, and I can implement both of them. So I can have more than one thing come after this. So I can say relatable, comma, I'll just put it on here so that you can see them both. Relatable 2. See the difference? So when you create an interface, this literally is the ultimate contract. That says that if I implement relatable, I have to create 3 methods. One has to be called equals, one has to be called is greater, one has to be called is less. All of them have to have a graded activity passed in. All of them must return true or false. Does that make sense? And let's change this around. Instead of Boolean, we'll make this one a string. You know, it doesn't matter. We'll make this one an int, and we'll make this one a float. So now, not only am I implementing that relatable that I just showed you, but a new class must also have these 3 methods. One called not equals that returns a string and gets passed in a graded activity. One called is greater or equal that returns an int and has to have passed in a graded activity. One that's called is less or equal that returns a float and gets a graded activity passed in. Maybe with these, maybe I pass in nothing. And a natural question would be, okay, Jeff, I even sort of get this. Why the hell would you ever want to do it? because you only can do single inheritance. So if you want multiple inheritance, you set up interfaces rather than classes, because you can implement as many things as you want to. Just like with extends, but you can only put one thing afterwards. With implements, you must put at least one thing, but you can have a comma-separated list. You could implement 50 things if you needed to. And that's how internally a lot of code is written. All right? Why? Because otherwise things get too big, and you can make them more generic in nature, and they're more shareable. And that's one of the hallmarks of object-oriented programming is reusability. All right, object-oriented programming, when it came out, it was not really that embraced by the computer science community until managers started to hear, well, you know, when you do this, it's going to result in a lot less code, because they started doing the ka-ching, ka-ching, and they said, ooh, that means that we can get rid of some of the people we have. We can do the same work with less people. Then it became more popular. Were you saying something?
You can extend and implement.
Yes, and you can do both. You're right. So, for instance, I could come here and say extends animal, and then the implements. That's fine. It doesn't matter which one you put first either. You can say implements, then extends, then implements. Most people put extends first. In fact, I don't know if I've ever even seen it the other way, but I think it's totally legit to do that. All right? Yes. Right. Yeah. And you save this, and you compile it. It's just a Java file. But you compile it along with your other programs. That's the key thing. And that's what they show in here. And that's exactly what I just showed you is what they talk about. It's not, there's really no, technically there's no inheritance even thought of in here. With the extends, with the extends, the implements is not, those aren't children though.
No, but the final class is a child of something else.
Yes, yes. But what I'm saying is, like right here, this is still a child of graded activity, but the relatable, you can kind of look at it this way. Let's just assume that any class that implements relatable, let's pretend for a second that for some reason this is all, we're creating some kind of an application for some kind of a soda company, all right? And I think I'm saying this because I heard this on a commercial the other day. Blake Shelton, and I like Blake Shelton, I like his music, but the guy hawks everything in the world on commercials. And I saw him telling you to try the new Pepsi that has sugar in it. I thought, that doesn't really sound new to me. But imagine that what you're implementing, all right, that your interface, it has sugar. So anything that needs sugar would be implementing that, so it would make sugar available to it. All right? What you're doing is you're defining, and usually, all right, with the example that they show in here, almost, this is actually, believe it or not, this is a great example, because normally the difference between, because I've been asked this question before, okay, it sounds like abstract classes are a lot like interfaces, all right, as an example. The big difference is abstract classes, it's legal to define methods in there, and those methods can be implemented. In other words, they can be full methods. You can't do that in an interface. The only things you could put in an interface are prototypes like this and constants. That's it. That's the way that they're set up. So if I had constants I wanted to be able to share, I could have added those in here too. All right. So again, I don't know with you guys, in all seriousness, how much you're reading the book or not reading the book, but I'm just trying to give you kind of an overview of what's going on. That's all. All right. There's a lot. They fill in a lot of the gaps. I'm giving you, basically the stuff that's in here. So they're showing here. There's where they are playing with some constants and multiple interfaces. I already mentioned that. Notice how it changes. The dotted arrow, that's the interface. And it's not, it's to the side because it's part of it, sort of, but it's not a child. There is no child type of relationship here, kind of what Mark had asked before. Yes, you put those out there, and that would be the kind of thing you could put it in a package, you could put it anywhere. So if I put it in a package, you have to implement it to use it. But if I've got 10 classes in that package, they can all implement it. Or only certain ones can, but only the ones that implement it can use it, type of thing. So there's still some code examples in here. I'm not going to go through this, but let's look at this because this will make Mike happy. All right. He asked me about the homework, and I think he maybe even started it, so he was mad if he did some work he didn't have to do. So, all right. So we talked about these programming challenges. Let's take just a couple minutes and look at all three of them. The first one here says, design a class named employee. The class should have the following fields, and you can read those yourselves. All right. And it tells you what the type of fields are, etc. You should know, looking at this, okay, name, string, that should make sense. Number, well, you start the thing integer, except it's digit, 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 dash, letter. So that's going to be a string, right? Boom, that should just make sense. Hire date, string. Write one or more constructors and the appropriate accessor and mutator methods for the class. Well, again, typically you're going to have a no-arg, and you're going to have one that fills everything. In this case, that would make a lot of sense. You could have separate constructors. I've seen this where people will show examples of like a person's first name, middle name, and last name, and they'll write one constructor that's a no-arg, one where you pass in all three, one that you pass things, you know, all the different permutations, which is kind of silly, but you could do that. Next, write a class named production worker, all right, that extends the employee class. So what does that mean? That means it's a child, correct? All right, of employee class. The production worker class should have those fields, all right, and that. The workday is divided into two shifts, day and night, and they each have an integer. One is day, two is night. Does that make sense? All right, they could have done 0 and 1. They could have done true and false, but this is the way that they decided to implement it. Write one or more constructors. So you've got a parent class here and a child class here. All that makes sense. You said it all makes sense. All right, so write that and one or more constructors, accessor and mutator for a class, and demonstrate it. All right. Then number 2. In a particular factory, a shift supervisor is a salaried employee. What does that mean? That means that they've got all this stuff, but they're not a production worker, so they don't have this stuff. Does that make sense? So imagine that this was in a thing by itself that went up to right here. So all that stuff that you see, all that stuff that's in blue, basically, all that stuff, that's just an employee. And all the stuff that's not blue that's here, that's a production worker. Well, a shift supervisor is all this stuff plus this. So it says you want to extend. So what we're talking about right now is we've got employee. Right? We've got employee. And for exercise 1, they tell you to take employee and make production worker. I'll just put PW. And in exercise 2, they ask you to come in here and put in shift supervisor. Okay? Then in step 3, they ask you to make a team leader. Does that make sense? That's the hierarchy. It actually is a fairly simplistic hierarchy because it's only 2 levels deep. Not that it matters, but again, since we're computer people, that's level 0. It's not level 1. All right, this is what this would be known as a level 1 inheritance hierarchy, level 0 and level 1. Go ahead. Is it? Oh, okay. Okay, in a particular factory, a team leader is a paid production worker. Thank you. All right. And you know, to kind of get back, I'd like you, because I think that you're right. Now that you're doing a 2-level hierarchy, I'd like people to do all 3 of these. All right. But I'm going to give you all next week, and probably the Tuesday of the following week if you need it. All right. So I'll give you all next week to work on it. And again, like I said, if you would rather work on them by yourself, that's okay. If you want to work with another person, that's okay too. All right. Now, Zach told me that he wasn't going to be here this afternoon. He said he had something else going on. All right. Zane didn't. Okay. So you keep that in mind if Zane's your partner, just so you know that. Okay. Because he was missing in action for a while last semester. He still got all the work done and did very well. And it's just being taped. So I'm not bashing him or anything for saying that. But you know that I think by and large everybody in this room has good attendance. But there have been times that even some of the people in here you slipped up for whatever reason. But if you want to work with another person, I guess the worst case scenario would be 3, but I don't remember. I could bring up, I thought there were 10 people in the class. All right, and if there's 10 people in the class, that works out evenly. Again, if it turns out that Mark says, I don't want to work with anybody, that's okay. But like I said, I think you can get something bouncing stuff off of other people. So I will, at a minimum, I will give you, we will talk about this next Thursday. Okay? It won't be due until 2 weeks from now. So today's the 21st, the 28th, what, 29th, 30th, is that the 4th? Something like that of September? All right, I think that's right, because I think the 1st is Labor Day. So that would make it the 4th. So 2 weeks from today, and a minimum, you'll get 2 class periods to work on. Again, I don't want us to be where we're spending so much time on lab that we can't get through the rest of the book and have time for Android. All right, that's why I'd rather give you a week. The good news is, I'm asking you this question. The employee, is there a lot of difference between the employee that we did and the person that we did the other day? All right, is there a lot of difference between, for example, the production worker and the customer that we did? No. So you've already got the framework set up. All right, and thank you, John, again for saying it, because you're right. So you want to make sure that team leader will extend production worker, but the other two, shift supervisor and production worker, all right, they will extend employee. Does all that make sense? So you've got a level 2, level 0, level 1, level. You've got a level 2 hierarchy. All right, and that's enough to ask from you. All right, and what does that mean? Well, that means that if you've got no arg constructors, you with me? If you've got no arg constructors, then you're not going to set anything. So if you've got a no arg for employee and a no arg for production worker and a no arg for team leader, and you instantiate one of those and you put them in double quotes, you still really should, if you're going to put in a no arg constructor, you can do it, but you should be initializing all those variables that are strings to double quote, double quote. So there is garbage in there, and if they're numeric variables, they should be being set to 0, and if they're Boolean variables, they should be set to false. If you say, well, that doesn't make sense to me, then don't do that. If you want non-no arg constructors for this one and this one and this one only, then do it that way. But remember, here, what you're going to have to do is if you want this to use some of this stuff, you're going to have to call super, correct? That'll have to be the first line. The first line in here will have to be super to call that. The first line in here will have to be super to call that. Does all that make sense? Anything that doesn't make sense? And again, if you say, well, none of it makes sense, but I just am too afraid to shake my head. All right, go back and make sure you've read the chapter. All right, I've gone through and I've used some code examples, and some has just been basically wordage to go with you. That's why, again, I'm creating the program for you first and having us do it together. So you can go back, oh, yeah, now that's why he did that. Oh, that's why he did that. All right? So, again, Tuesday of next week and Thursday of next week will both be labs. All right? And we'll talk a week from today, but it's not going to be due until 2 weeks from today. It's one assignment, even though it's got 3 components or 3 pieces. If you want to, in the same package, if you want to go and create employee, and then in the same one, then do production worker and get that done, then then come in and do shift supervisor in the same package, and then that's the way I do it. All right. Questions? It's one assignment. What I'm saying is you can, if you want to, you can do it as 3 assignments. You know what I'm saying? You could do that. You could even copy in, do employee, and just put production worker in there. Then make another, another project and copy in employee, and then put shift supervisor in it. You can do that if you really want to. All right. Well, it's not only is it easier to put them all in one, that's the way you do it in an actual application type of thing. That's the way you would do it in there. All right. So it's going to give you a chance. What you're going to notice is you're going to have more files in your Eclipse folder than you normally would have. All right. And just so you know, not that it's a big thing now, because it's not going to happen till next month sometime, but in the next chapter that we go through, I'm not going to spend much time at all on the file stuff. I'll talk about it, but you won't have any homework on it. Nothing with files. But we will talk about exceptions. And you'll learn how to throw exceptions. You'll learn how to write your own exceptions. It's not hard. All right, it's very straightforward, I think, and it actually is something that makes sense. Now, if Mike writes a program and it says, what's your age? And somebody puts in, none of your damn business. The program won't blow up. You'll have an exception that'll handle it that says something like, you are not allowed to enter a non-numeric value for this field. All right, and we'll use try, catch, and finally to do that. That's actually, after this chapter, it's probably a little bit more of a fun one, for lack of better words. No, there really is. The question was, that's actually a real good question Mark just asked. Do we have to worry about validation? The answer is yes, but only for one thing, and that is the employee number. Yeah, that employee number, if you remember, it was, yes, number dash letter, so it has to be in that format. Okay, if you make data string, that's okay. You know what I'm saying? So I'm saying is, Java has a date class. I could force you to use the date class, but it gets very quirky, for lack of better words, and it could result in your programs being a lot bigger. If you want to try that, go ahead and try it. All right, no, I don't want to try it. This is plenty. Then don't try it. All right, but the other stuff that's in here, I think at least looking at it, should make sense. Now, as far as, again, the question you asked about validation, think about. No, that's okay. I'm just going to take for granted that you won't. But if you ask somebody their salary, technically, when you think about it, you should now be at the point of sophistication where you're checking to make sure it's at least zero. If they're a volunteer, they won't get a salary maybe. All right, but you shouldn't. What's your salary? Negative $300. Yeah, I work for the place, but I pay them to let me work. We were talking this morning about Microsoft. How yeah, it should. Well, that's the thing is with numeric, then you're going to have to really start doing exception handling. All right, and then you'd be looking for number format exceptions, and we'll talk about that in Chapter 11. But you really should be checking it for viable values. All right, there's a difference between validation and viable values. All right, I can validate something. I can validate a phone number, right? I can make sure that you put it in there as parenthesis, number, parenthesis, space, number, dash, number, correct? I can do that. But saying that, I can put in there for your phone number 000 dash, or in parentheses, 000 dash 0000. That's valid from what you just told me. So that's like a reasonableness check. It's kind of like if I say that you have to work a positive number of hours. Well, technically, then how many hours can you work a week? 168. Mike might feel like he works 168 hours a week. All right? And Cody might make him feel like he works 168 hours a week. But technically, a reasonableness check would say probably a human being over time, you couldn't, even this would be stretching it, couldn't work more than 84 hours a week, right? Because that's 12 hours a day. And sooner or later, you're going to die young anyway from something like that, even if you're making money hand over fist. So if you want to start to implement reasonableness checks, because that's what we're moving toward. But at a minimum, yeah, you should at least say it's got to be positive. I guess if you want to stick $1 gazillion in there for a salary, you could do that. But if you want to put limits on there, and even that, if you're going to do that and put limits on, you should be really using constants. Max salary, min salary type of thing. All right, why? Because your program reads more English-like, plus if it ever changes. No, you can work here, but you've got to make at least $1. You ever see those ads now where the CEO agrees to work for $1? Oh man, are they fantastic people. They don't tell you that they're getting $15 million in stock options, but they're only working for $1. You know what? You give me $15 million a year, and I'll work here for $1 a year. I'll do that. But see, the thing is, knowing this school, they'd give me $15 million in Blackhawk stock, and that wouldn't be worth $15 million. So.
Some of them just don't have the company anyway. So
Yes.